Welcome to another tutorial by Longhorn Physics. In this tutorial we want to take on what we call horizontal projectiles. So here's the problem. We have a cannonball that is launched horizontally at 25 meters per second from a cliff that is 15 meters high. How long is it in the air? So in this case we're going to have a horizontal projectile which launch horizontally. See if I can do something like that. But before we can, and we know the height is 15 meters, and we know it's launched 25 meters per second. So before I solve my problems, I always like to go over all the basics, like the equations and the units needed to solve a problem like this. So in order to calculate how long the projectile is in the air, we actually have to derive the equation we're going to need to use. So we always have to go back to our basic kinematic equations. I like to call these the three amigos. We have VF equals VI plus AT. We have DY equals VI times T plus 1 half AT squared. And we have VF minus VI squared equals 2AD. So if we're going to figure out how long it's going to be in the air, that would bring us down to these two equations. There's no time in this one. So how do we decide between these two? We're going to need to use the distance in our problem. So this is the only one that has distance. So here's the amigo we use. Now let's look on this side, and we're deriving it now. We got to make sure we have our components and our labels to help us do this. So the dy direction, we'll set it up using that subscript. So we have dy equals vy I, which is your initial speed in the y direction. We know that's 0 because there's only a horizontal component, times the time plus 1 half AT squared. So we have the first part, which is 0, and we know that the acceleration is due to gravity. So we're going to substitute g there, and then we'll use a little bit of our algebra skills here, and we wind up with the equation t equals square root of 2dy divided by gravity. So before we solve the problem, let's make sure that we know all the units that go with the symbols in our equation. So we'll have t, which we know the final answer will be in seconds, and we have distance, which will be in meters, and gravity is meters per second squared. Alright, so let's finally solve the problem, and at the same time show you a method I like to use to solve physics problems. So now we know the symbols, we know the units, we have our equation. So all I like to do is read through the problem, and I like to circle and label all important information. So it's impossible to label it if you don't know the units and their matching symbols for the equation. So I know meters per second is V, that's speed in physics. How long is T, meters is distance. And it's not a bad idea to maybe sketch out on your draw a little diagram of what's going on. That might help you solve the problem also. Then I like to set up a little what I call a T-bar here with my knowns and unknowns, and then I'll start writing them in here to the table here. And then once I have them all on the table, it's easy to see where they go in the equation, and I'll just substitute there. We know gravity. Gravity wasn't given in the problem, but we got to assume it's 9.8, and that the problem was done on Earth and nothing else was said about it. So we got 2 times 15. Notice how I have this in parentheses, because if your calculators don't know what to do unless you tell them exactly what they need to do. And so if you just do it without the parentheses, you could end up with an operation error. So in the final calculation here, make sure you take the square root. We end up with 1.75 seconds. So this tutorial is part of my book called My First Physics Book of Motion. It's a 153-page book that's designed for students new to physics from high school to collegiate level. It makes sure that you learn the fundamentals, the terminology units, as problem solving and problem solving skills. So you show 2 different methods there for solving problems. The study guide takes a hands-on approach, has many interactive tables, worksheets, and mini quizzes. And then, of course, you see how this is referenced to the book. It's available at starstudyguide.com or straight at amazon.com. I guess typing these keywords would help you find it. But if you go to starstudy.com, spelled with 2 A's there, you can link to Amazon. If you think you want to see more about the book,